All right, let's talk about number 4 on the practice exam. This one is the synthesis problem. You have a starting material, you have a product. The interesting thing about this one is that you can use this as the only source of carbon. So you're not going to bring carbon in using any other compound, right? So that's sort of an interesting thing that's going on in this problem. And when you do that, I think it helps, at least for me, it helps in the retrosynthetic analysis, because I know I'm looking for 3 carbon pieces, right? I don't need to look for a 2 carbon piece or a 1 carbon piece. I'm looking for those 3 carbon pieces. So hopefully we look and we see that we have a 3 carbon piece here, a 3 carbon piece here, and then a 3 carbon piece here, right? So those are the 3 different molecules that we're going to start. Well, this is going to transform into those pieces of the molecule, okay? And so let's redraw so it's not so confusing, and think about our retrosynthetic analysis. So we have a tertiary alcohol, and when you have a tertiary alcohol, we have several ways to make it. One thing that's really interesting about this tertiary alcohol is that you have 2 groups that are the same, right? If you look at those 2, they're both isopropyl groups. And when you have 2 groups that are the same, that gives you a really important clue about where this molecule can come from, right? Because you could imagine, thinking retrosynthetically, that those 2 pieces could come in one reaction where you have 2 equivalents of isopropyl Grignard reacting with 1 equivalent of an acid chloride, right? Because we've seen when you do reactions of acid chlorides, you do 2 addition reactions, right? You do a carbonyl substitution reaction to go from the acid chloride to a ketone, and then the ketone reacts by an addition reaction to give you that tertiary alcohol. All right, so that's a really key disconnection, and it simplifies this problem in a major way, because now you can see we just have to make that bromide, right? We know that the acid chloride comes from the carboxylic acid, right? And we know that the carboxylic acid comes from a primary alcohol. So now we're thinking about, can we make this bromide and that alcohol from the alkene that we started with? And we know how to do that, right? So I think the key is that first disconnection, and then really working through the reactions that we're hopefully quite familiar with. All right, so let's do the synthesis of this compound. So if we need to make isopropyl Grignard, we can just react the alkene with HBr, right? And that gives us the bromide that we need. All right, so we'll save that and make the Grignard in just a minute. If we need to make the primary alcohol, the only way we have to make the primary alcohol is hydroboration oxidation. The other hydration reactions will give us a secondary alcohol, so we need to be very clear that we're doing hydroboration oxidation. Okay, and then we can add chromic acid. And again, that's the only way we can do the oxidation to give us a carboxylic acid. PCC would give us an aldehyde. And then we can react it with thionyl chloride to give us the acid chloride that we need. Okay, and then finally we can complete the synthesis, take the isopropyl bromide, react that with magnesium, add in the acid chloride that we just made, and then an acid quench, and that's going to give us our target molecule. Okay, so again, I think this synthesis looks a little challenging at first. If we think very clearly about how to do some retrosynthetic analysis, breaking off those 2 isopropyl groups, it reduces down to a synthesis that isn't too bad and is something that we can handle, and something we should be prepared to do.